In this experiment, we'll be talking about we'll be configuring switches and routers. So this experiment is basically a continuation of the last experiment in which we had two switches and two PCs. We configured the switches and then used the PCs to send a packet from one PC to the other PC, and also telnetted or used telnet sessions to the switches to log in. Now in this topology we have three PCs connected to a switch which is connected to a router. All these connections are done by a copper cable, and the connection between the routers is done by a serial wire or DC cable. The DC basically stands for data communication equipment and has a clock rate of 64,000. Now in order to enable the serial connection, we need a serial interface. So in order to do that, we go to the router. We need the HWIC2T model. We drag and drop this model out here. We need to switch the router off, drag this and switch it on. So the HWIC2T provides two serial ports and Ethernet connectivity. Yeah. So now, since I've already configured the switches last time, we'll be just working on the routers this time. So in order to configure the router, we have the following commands. The commands are similar to that of the switches, but later on they change a little bit. Basic the interfaces and the serial interfaces. So we start with the enable command in config T, and then we keep a host name for the router. Then enable secret Cisco is basically a secret kept to protect your device. Then you configure the line console. You provide a password for the line console for login. Then you exit. Then line VTY again is basically to enable virtual connections to your device. So 0 to 4 basically enables 5 connections for login local. Now the transferred input telnet transferred input SSH is again used for establishing telnet and SSH connections to your device, and this username and password will be used to protect your device or to provide credentials for your telnet or SSH session. Service password encryption is again used to encrypt the plain text password which has been stored. Then you exit. Then you need to configure the two interfaces. First is the gigabit interface from router to switch, and then is the serial interface which is from router to router. So gigabit Ethernet, you'll basically provide you'll set the IP address. So I've already done that out here. So as you can see, the gigabit Ethernet 0.0 is 10.0.0.1/8. Then you provide the speed as 100. Now interface serial 030. Now you need to configure this interface. So you'll provide an IP address of 20.0.0.2, subnet mask of 255.0.0.0, and no shutdown basically sees to that your router doesn't shut down, so it stays in an active state. And bandwidth 128 is provided since the connection is serial, you need a bandwidth for that. So exit. Now this is very important as this decides the route of the IP packet from one router to the other router. Now for this basically there are three parameters. So the first parameter basically tells us from this router where the packet will go to which network. So this network is not 20.0.0.1, it's 20.0.0.0, this whole network. So you specify 20.0.0.0, then you have the subnet mask of 255.0.0.0, and this is the next hop address. So from this router to this router, this would be the next hop. So 30.0.0.2, this would be the next hop. And then similarly for router 2, for the right router, you will be configuring this. You will change the host name in router right, and enable secret Cisco will protect your device. And line console will protect. You can configure your line console, provide a password for login. Then line VTY again will establish the 5 virtual connections. Login local telnet SSH. Again for telnet and SSH sessions, and then you can provide credentials for your sessions. And password encryption is basically to configure your plain text to encrypted form. Then again, this would change out here. So for the gigabyte interface, this will become 20.0.0.1. High subnet mask will be provided, speed will be 100. And then for the serial interface, it specifies the IP address out here, which I've already done out here. So from 10.0.0.1, this will change to 20.0.0.1. After this IP address has been assigned, you put the no shutdown mode and provide a bandwidth speed. Then the IP route for this router would change because the network out here is 10.0.0.0. So that would be a network for this. Then your subnet mask, and then your next hop which would be for this router, which is 30.0.0.1. And then you provide a default gateway of 10.0.0.1. Now we'll try to simulate or send a PDU from this PC to this PC having IP address of 10.0.0.2 to 20.0.0.0.4. So you get the simulation. So now firstly your PC, your packet grows from from PC 0 to switch 1. You can see the PDU details out here. So your inbound would have a Ethernet 2 header, and your outbound would have a Ethernet 2 header. So the source address can be seen out here, and the destination address, which would be a router's destination address, can be seen out here. Similarly for the PDU, you can see the source IP address and the destination IP address. Next step will go, so it goes from the source to the router. Here the inbound details is Ethernet 2 header, and outbound detail is HDLC header. So then this will go from the router, this router to this router. Then from this router, it will go to the switch. Now at the switch you can see the destination MAC address of the PC we are trying to send. So 0002 FD, you can see this under, or you can see it in our inbound details. So you got the information that you need to send that to 000C.2FT from the switch's physical address, source address. Same for again the header changed from Ethernet to Ethernet 2 from HDLC because this switch not router. And then finally your packet reaches your IP address of 20.0.0.4. Yeah, that will be all. Thank you.